Hi there, welcome back to my channel. In this video, I have a problem in double integrals over polar region. So here, it said determine the volume of the region that lies under the sphere x squared plus y squared plus z squared is equal to 9. Above the plane z is equal to 0 and inside the cylinder x squared plus y squared equals 5. So if we model this, we're going to have something like this, right? So this is our cylinder. And this is where we want to find the volume because the region said is inside the cylinder and it is below the z plane, right? So it lies under the sphere. So it lies under the sphere. This is the sphere, right? So the reason why it's there, so for the sphere you can get the radius of the sphere to be 3, right? So in the z plane you have 3 on the z plane, right? So this is a three-dimensional figure, okay? So on the x and on the y. So I'm just using this to illustrate what the problem is talking about. So for us to solve this problem, we know that to find the volume of this region, we are dealing with what? Double integrals, okay? So for these double integrals, always you say v is equal to double integrals over the region and the function of f of xy, then the a. So let's see something. Now our boundary or our region of integration is what? This, a cylinder, which is x squared plus y squared is equal to 5. You realize that this region here is not something simple to be done in the Cartesian coordinate. But if I send this one to the polar coordinate, it's going to be so simple because x squared plus y squared in the polar coordinate is the same as r squared, okay? So I'll say r squared will be equal to 5 and my r will be equal to square root of 5. Okay, at this point I can say my r is what? Greater than or equal to 0 but less than or equal to square root of what? 5, right? So I've just got my r, the limit for r. Now what about theta? This is a complete cylinder. When it collapses on the xy plane, remember that you're going to have a perfect what? Circle, okay, appearing on the xy plane. And this rho is towards the point 3 to give us what? Our diagram as a cylinder. So therefore, our theta will be greater than or equal to 0, but less than or equal to 2 pi. Once you have these two parameters, what else do we need? We need our actual function, which should be in the form of what? Our r and what? Theta, right? So you make z squared the subject that is equal to, because it's the plane is where z is equal to 0, z squared equals 0, right? So let's see. So z squared is going to be equal to 9 minus s squared minus y squared. So our z is simply equal to square root of the expression 9 minus s squared minus y squared. At this point, since we want to simplify this in the polar coordinates, I'll have to convert this one towards a polar form. So z will be equal to square root of 9 minus the expression s squared plus y squared, also the same as r squared. Is that not it? Yep, so this is what we get as our function. So at this point, we have now converted everything to the polar form. I'll have my outer integral having what? The theta, as I told you, outside 0 to 2 pi. Then I'll go inside from what? 0 to what? Root of 5. So from 0 to root of 5. Then I'll have my function as square root of 9 minus r squared. Then r d theta. Okay, as simple as that. So once I have this expression, then using by substitution, our integral simply is equal to outer 0 to 2 pi. Then when I differentiate what I have inside, I'll have what? Negative half, right? Negative half r. Negative half r. Sorry, I'll have negative 2r. Then you know by the principle of integral, you have to divide that. So our r and r will cancel. This stuff should be something you know. I mean, it should be basics at this time. So I'll have negative 1 over 2, right? Then I'll have the whole expression. So this expression will be u to the power half, right? U to the power half. When you add 1, you get 3 out of 2. So you'll be getting 2 over 3 times u to the power 3 out of 2 as your derivative, right? So as your integral. So I have negative half times 2 over 3, then times 9 minus r squared all to the power 3 over 2, the r. So that is for the r part, so the theta. but I'll have to introduce my limit 0 to root 5, right? So let's see the expression 0 to 2 pi. This gives me what? This cancels this. So negative 1 out of 3. I'm having 9 minus r squared to the power 3 out of 2. The limits are from 0 to root of 5 d theta. So at this point, when I put my root 5 inside, root 5 squared to be 5. 9 minus 5 is what? 4, right? Then 4 to the power 3 out of 2. What will that give me? So I also have 0 here. So after doing the computation, you should get 0 to 2 pi of the expression 19 over 3 d theta, right? D theta. So this is equal to 19 on 3 theta 0 to 2 pi. That's going to give me, when I put 2 pi here, obviously I get 38 over 3 pi.